This is my Algebra 1 video that discusses solving one-step equations with multiplication and division. This is part 1 of a two-part series. But before we start, there's something I would like to go over. And that is, in algebra, whatever you do on one side of the equation, you must also do on the other side of the equation. And here's an example. I have 8 equals 8. This is true, right? Everybody knows that. So the next thing is if I multiply this side by 4 and do nothing to this side, it is no longer true. Because on this side, I would have 4 times 8 equals 32. And 32 does not equal 8. So if I was to multiply this side by 4, I must also multiply the other side by 4. When solving one-step equations with multiplication and division, we use multiplicative inverses. These are used to get the variable on one side of the equation and numbers on the other side of the equation. So at the end of the day, you would have x equals something or y equals something. Multiplicative inverses will equal 1 when they are multiplied together. Additive inverses, if you remember, will equal 0 when they are added together. But now we're dealing with multiplication and division. So you may ask, how do I find a multiplicative inverse of a number? Well, you would take that number that you want to find a multiplicative inverse of and divide it into 1. Here's an example. I have 34. What is the multiplicative inverse of 34? Well, we will take 34 and divide it into 1. Here's an example. 1 divided by 34. Now let's see if they will in fact equal 1 when they are multiplied. Well, I can take this 34 and just make it 34 over 1, which makes it easier for a lot of people. So we have 34 times 1 equals 34. 1 times 34 equals 34. And 34 divided by 34 equals 1. How do I find the multiplicative inverse of a number? Once again, we take that number that you want to find the multiplicative inverse of and divide it into 1. Here's another example. 5, 6. So I will have 1 divided by 5, 6. Now if you remember when you were working with fractions earlier, when you divided something by a fraction, you would turn that into a multiplication problem by flipping that fraction, right? Using the reciprocal of 5, 6 is 6/5, correct? So now 1 times 6 is 6. 1 times 5 is 5. That equals 6/5. Now this is the multiplicative inverse of 5, 6. Let's see if it works out. We're going to multiply them together. 6 times 5 equals what? 30. 5 times 6 equals 30. And 30 divided by 30 equals 1. So 5, 6 and 6/5 are multiplicative inverses of each other. And you can remember when it comes to finding the multiplicative inverse of a fraction, all you have to do is flip that fraction. Here's some more examples of multiplicative inverses. 7. What times 7 will equal 1? Or can I divide 7 into 1 and I will get 1/7, correct? Let's see if it works out. 7 over 1 is the same as 7. Times 1/7. 7 times 1 is 7. 1 times 7 is 7. And that equals 7 divided by 7 equals 1. So 7 and 1/7 are multiplicative inverses of each other. Here's another example. 1/2. Remember what I was saying about fractions. You can just do what? Flip that fraction, right? So then I have 2 over 1, which is this flipped, or the reciprocal of 1/2 is 2 divided by 1. So you got 1 times 2 is 2. 2 times 1 is 2. 2 divided by 2 is in fact 1. This is because 1/2 and 2 are multiplicative inverses of each other. Now, we're going to solve a one-step equation with multiplication and division. Here we go. 5 times x equals 25, or 5x equals 25. So, we want to get the variable by itself on one side of the equation and the numbers on the other side of the equation. So, we have 5 over 1, right? Then we're going to take the multiplicative inverse of 5, which you take 5 and divide it into 1, or you can just flip the fraction, and we're going to multiply this together, right? So this is going to equal, but we have to do it on both sides, right? We have 25, so we also have to multiply 25 over 1 by 1/5, correct? So 1 times 5 is 5. 5 times 1 is 5. We just bring the x down. 25 times 1 is 25. 1 times 5 is 5, correct? So we have 5 divided by 5, which just equals 1. You can say 1x or just x. And 25 divided by 5 is 5. So x will equal 5 for this equation. Now let's see if that works. Here is x equals 5. This was our solution. 5x equals 25. 5 times 5, well, we would just substitute 5 for x, equals 25. And that is true. Now we're going to solve a one-step equation, the same one with multiplication and division. But this time, instead of using the multiplicative inverse, we're just going to use the opposite or inverse operation. And multiplication and division are opposite or inverse operations of each other. So we're multiplying the variable by 5. See, 5 times x equals 25. So what we're going to do, we're multiplying by 5. So now, in order to get the variable by itself, we're going to do the opposite, and that is divide by 5. But you must do this on both sides, correct? In order to keep the equation true. So 5 divided by 5 is 1, right? And 25 divided by 5 equals 5. Same as before. Now we use the opposite or inverse operation, which we were dividing by 5, in order to get the variable by itself on one side and numbers on the other side of the equation. Here's another example. 3/4 x equals 12. What is the multiplicative inverse of 3/4? And remember, when we're working with fractions, we just flip the fraction, correct? Let's see if that works out. If 4/3 is in fact the multiplicative inverse of 3/4. Here's 4/3, here's 3/4. 3 times 4 is 12. 4 times 3 is 12. 12 divided by 12 is 1. So it is true that 4/3 is the multiplicative inverse of 3/4. So then we're going to plug that in we're going to use that multiplicative inverse in order to solve this equation, right? So we have 4/3 times 3/4. This is a 3/4 times 4/3. And then we just bring the x down. But we have to do this on both sides in order to keep the equation true. So we have 12 over 1, which is the same as 12, times 4/3. That's the multiplicative inverse of 3/4. Now, on this side, we have 4 times 3 is 12, 3 times 4 is 12, and on the opposite side, 12 times 4 is 48, and 1 times 3 is 3. So now we have x, because this is 1, 12 divided by 12. It just leaves the x by itself. And then on the other side, 48 divided by 3 equals 16. So x will equal 16. Let's see if that's true. Here is x equals 16. We're going to plug 16 into our equation for x, and let's see if it works. 3/4 times 16 over 1 equals 12. Is that true? Let's see. 3 times 16 is 48. 4 times 1 is 4. Then 48 divided by 4 is in fact 12. So you would have 12 equals 12, which is true. Now here's another equation. This time we're going to use the opposite operation, correct? So here's 12x, right? We're multiplying the variable by 12, and it equals 48. Okay. So now remember, the opposite or inverse operation of multiplication is division, correct? So we're going to multiply both or divide both sides by 12, correct? Because 12x is the same as 12 over 1. So we're going to divide both sides by 12. And here we have 48, we have 12 divided by 12 is 1, x, which is the same as x. And 48 divided by 12 is 4. So let's see. 12x equals 48. Plug in 4 for x. Does it work? 12 times 4 does in fact equal 48. So it is true. Here's a little review of what we just covered. With one-step equations that use multiplication and division, you always want to get the variable on one side of the equation and the numbers on the other side of the equation, like x equals something, y equals something. And whatever you do on one side of the equation, you must also do on the other side of that equation in order to keep the equation true. And multiplicative inverses will equal 1 when they are multiplied. And the inverse operation of multiplication is division. This has been my Algebra 1 video, One-Step Equations with Multiplication and Division, Part 1. You can reach me, R. Jansen, at janssenmath620@gmail.com.